We're going to move on to part 2 of 2.2, which is we're going to talk about symmetry and definition of even and odd functions. All right. So the first one is we need to define is what is an even function. Okay. So here's an example. We're going to do an example of f of x is equal to x squared. So what we're going to do is we're going to put in an x value. All right. So f of x is 2 equals, replace x with 2, 2 squared is equal to 4. So in order to figure out if it's an even function, we need to replace our x with a negative x. So let's put in here negative 2, and we'll put in negative 2 here, and then we need to square it and see what the outcome is. So negative 2 times negative 2. Now notice I put this in parentheses because if you're using a calculator, you need to make sure that you put this in parentheses because negative 2 times negative 2 is 4. If you just put in negative 2 without the parentheses, your calculator is going to say it's negative 4. So let's look at the results. The definition tells us if we put in a negative x, so we put in a negative 2 for our x value, and it came out. So it says if it comes, the answer, your y value comes out as the same as the original number for x, 4, and it equals 4, then it's considered an even function. So this was my original x, and when I put in my original x value, it equaled 4. When I put in my negative 2, I got the same one. So because I got the same values, this is considered an even function. So let's look on a graph. So let's say, because of my example, this is going to be 0, 0. And then I come up here and I have 2, 1, 2, 3, 4, 1, 2, 3, 4. All right. So if I looked at this on a graph portion, so this is 2 comma 4, right? I inputted 2, I got a 4. I inputted a negative 2 and got a 4. All right. So if I notice about this graph is that these are symmetric. So here's my original x, and then I did the negative x, but I still got the same answer. So we could say, if we were to look at a graph, okay, we could say that the graph of an even function is symmetric with respect to the sorry about that, y axis. So another symmetry means we have a mirrored effect. If we were, here's our y-axis, all right? If we were to put a mirror here, we're getting the same picture, all right? So that's considered, all right? So symmetry with respect to the y-axis, we can call it an even function. And again, we're just redefining, not redefining, we are just giving it another name. We're just looking at our functions. So let's look at odd. So here's an odd function. So if it's an odd function, again, if we put in a negative x, then if it equals the negative of the original y value, then we would consider it an odd function. So here's our example. Let's do f of x is equal to x to the third power. So I'm just picking the number 2, all right? That's my original x. If I put it into my equation, so 2 raised to the third power is equal to 8. So I want to know is if this function right here is x cubed an odd function or an even function or neither. I want to put this in. So it tells me, the math world tells me, all right, put in a negative 2, put in the opposite of whatever you have for x. So I use 2. So when I put in a negative 2 here, and I can put this in my calculator, and I can go negative 2 times negative 2 times negative 2, I end up with a negative 8. So I'm going to look at this. I don't have the same values here, so it's not even, because if I had the same value, it's even. but my original y value was 8. And if I do the opposite of positive 8, it is negative 8. And that's the definition of an odd function. So this is an odd function. So if I was to graph this, I could put this in my calculator. I'd be at 0, 0. I can go 2 to 8, which would be right here. This would be my 2, 8. And then down here would be my negative 8. So this would be my negative 2, negative 8, because this is my x value. This is my y value. I input something, and that's my output. And if I was to draw this graph, it would look something like this. All right. So I don't have symmetry. So up here, we did symmetry along the y-axis. So this one, how am I getting my mirrored effect? I'm not getting a mirrored effect with my x value, but what I am getting is if I was to draw, sorry, it's not perfect here. If I was to go and do one across the origin, so if I looked here and then I mirrored it, so if I took it from here and I mirrored it, it would come down here over the origin. I have a mirrored effect or symmetry. So what we can say is the graph of an odd function is symmetric with respect to the origin. So how does this help us? This is if we put it in our calculator instead of having to do the math here, we could easily put it in our calculator and look at the graph. Or if they gave us a graph, we could say, oh, this is an odd function. This is an even function, which tells me that if I input an x and I take the opposite of an x value, it's going to give me the opposite of a y value. So it kind of gives me a picture of what this looks like. You have to remember that mathematicians didn't have the technology that we have. So instead of having to draw all of these out, they came up with something that's called like the algebra test. Or if they looked at um, so they didn't have to draw these. You have to remember, sorry, that these mathematicians had to draw everything, every type of function, and they had to find some patterns. And so that's why this was discovered. And today's math world, we want you to be able to look at a graph and tell us when is it increasing, when is it decreasing. I'll put this here in case you need it. Decreasing, when is it constant? What does it look like? Is it an odd function? If it's an odd function, it's telling me this. If it's an even function or if it's neither. We just want you to be able to discuss what the graphs are. All right. So now let's look at, we're going to determine whether each of the following functions is even, odd, or neither. That is an option. Then we're going to determine if the graph is symmetric with respect to the y-axis, sorry about that, the origin, or neither. So this is what we did in the first two examples, it's called the algebra test. So this is what we're going to use. We're going to replace an x value, and we can pick any x value with negative x and simplify. Once it's simplified, we're going to look. When we put a negative x in, was it our original f of x? Now remember, these are y's, okay? When we put a negative x, was it an opposite of our answer? Or when we put in a negative x or an opposite x, it's neither. So let's do the first one. And again, we're going to put in negative x. So we're going to go, here is f of negative x is equal to 2, and then I'm going to put parentheses, where my x's are minus parentheses. Okay, so wherever my x's are, I'm going to put a parenthesis. So now what I'm going to do is I'm going to put in is a negative x and a negative x. And now I'm going to simplify. So this is equal to, all right, if I take and multiply this 3 times, if I go negative times a negative times a negative, I'm going to still end up with a negative here. So this is going to end up being a negative 2x cubed. Now what happens when I have a negative and a negative? I end up with a positive x. So what I'm looking for is I'm looking back at this original and I'm saying, okay, is this exactly the same? And I'm like, nope, this is not a positive 2x cubed, and this is not a subtract x. But what is happening? This is a positive 2. This is a negative. So it went opposite. This is a negative, and now it's a positive. So this is actually the opposite of my f of x here. This is my f of x. So this is actually opposite. Positive 2, negative 2, negative, positive. So if it is opposite, I'm going to come down here. If it's the opposite f of x, I can call this an odd function. And if it's an odd function, then it is, its symmetry is about the origin. So I can say origin symmetry. Let's try another one. All right, so let's try this one. So we're gonna go put parentheses first of where my x's are. So this is f of x is equal x to the fourth plus 3x squared minus 2. So here we go. Parentheses plus parentheses minus 2. So I'm going to put in, do the algebra test. I'm going to put in a negative x, negative x, negative x. So if I go here, this is going to be, let's see, if I take anything to the power, that's going to be a negative times a negative is positive, times another negative is a negative, and a negative times a negative is another positive. So this is going to be x to the fourth plus anything squared, negative times a negative is positive, plus 3x squared minus 2. All right. So now I'm going to compare these. I'm going to compare my answer when I put in negative to my f of x, because that's what the algebra test says to do. So I have x to the fourth, and it's positive. I have plus 3x squared, plus 3x squared. So I'm same there, minus 2, minus 2. So these are exactly the same. So when I did this, I got the same f of x. So going down here, if I replace a negative x, do I get my same f of x? I did, so this one is even. And by definition of even, I know that I have symmetry along the y-axis. So I can say that this function is an even function and it is symmetric along the y-axis. So it's going to reflect along the y-axis. All right, let's try one more example. So here we go. We're going to put in our negative x. I'm going to put parentheses where my x is going to go in. So according to the algebra test, I'm going to put in a negative x here. Sorry, negative x. When I input a negative x here, when I take something to an odd power, it's a negative. So I get negative x to the fifth minus 3. So I need to compare this. All right. Now, here is I go from a positive to a negative. So I've got opposite here. But then when I look at negative 3, then I have something that's the same. So I'm going to put a little note here. This went opposite of f of x, opposite of f of x, where this negative 3 stayed the same. Well, I either have to have where it's exactly the same or they're all the opposite. Like on this one, we went from positive 2 to negative 2. We went from a subtract or a negative x to a positive x. Here, everything is the same. Everything on this one went opposite. This one I have opposite and the same, so this one is considered neither. And remember, when we look at what we're comparing our original to our new equation. All right, so that is part 2 of 2.2. So that is even and odds and symmetry. So I'm going to stop this video so that we can do part 3.